Hi, in today's lecture, we will be discussing how to represent a negative number. A negative number representation in digital electronics. Number representation negative number representation in digital electronics. Generally, as per our normal nomenclature, there will be three different types of negative number representation. One, the sign magnitude method. Magnitude method. The second, one's complement. Third, the two's complement. So there are three different methods. So before discussing anything, first of all, we will be discussing first the sign magnitude method first. Later, what are its representation, advantages, and disadvantages. All the three different things we are going to discuss in the today's lecture. So first let us consider about the sign magnitude representation. The sign magnitude representation. Yeah. So the sign magnitude representation. Whenever I'm talking about this sign and magnitude representation, the name itself explains us like there will be an 1 bit representation for the sign and the magnitude. For suppose as we will be using 1 bit representation for the sign, one extra bit. Therefore, so let us consider for one extra bit we will be having two possible combinations 0 and 1. So we will be considering for a positive number we will be considering the extra bit, the bit as 0. And for a negative number we will be considering the extra bit or the sign bit as 1. So for suppose if I want an example, if I want to represent a number -3, okay, so generally for representing 3 we require 2 bits, 1 1, which we are going to call it as a magnitude, and for representing the minus we require one extra bit. As it is a negative number, as per our discussion we will be considering 1 here. So this representation gives us -3. So similarly, just as another example, let us consider how can I represent +3. So if I want to represent the +3, here the magnitude of the +3 is going to be 1 1, and whatever the sign bit I'm going to represent it by 0. So here this represents the magnitude and this represents the sign, and even here this represents the sign bit. Okay, so now let us take this to a next level. So let us consider, yeah, I want to represent a number of -3, -2, -1, 0, Just a second. So now let us try to represent this one for -3, -2, -1, 0, 1, 2, 3. So why do I want to represent for all these things? You will get to know in the next few minutes. So initially, as it is, first let's write down the magnitudes. So this one will be 0, 0. This one will be 0, 0. So this is 0, 1. This is 1, 0. This is 1, 1. Here also the magnitude is 3, so it is 1, 1. Here the magnitude is 2, so 1, 0. Here the magnitude is 1, so 0, 1. Here the magnitude is 0, 0, 0. Now let us add the sign bits. Here the -3, it is negative, so the sign bit is 1. Negative, sign bit is 1. Negative, sign bit is 1. Positive, the sign bit is 0. And here the 1 is, I can consider the sign bit to be 0, sign bit to be 0, sign bit to be 0. Okay. So now here there is a problem which occurs. So if I'm taking 0, 0, and if I'm considering the sign to be 1, obviously it will become -0. So here we can observe that the 0 is having two representations. So that will be the major drawback. So what is the disadvantage of this corresponding method? 0 is having 0 is having two representations. Is that okay? So 0 is having two different representations, which is the disadvantage. Yeah. And in some of the previous gate questions and all, they have been asking about the range. So as that comes under the same topic, let us complete that concept even. So what is the range of the numbers which you can represent? What is the range of the numbers which you can represent by using 3 bits? Okay. So for the 3-bit representation, you are representing the data from -3 to +3 using 3 bits. So let us just put forward the information which we are aware. So by using 3 bits, you are able to represent from -3 to +3. Okay. So here, one more information which we are having is we are using one extra bit for sign representation. So let us just consider that, like I can also write down the 3 like minus of 4 minus 1 to 4 minus 1. So here minus of, instead of the 4 I am writing it as 2 square minus 1 to 2 square minus 1. Okay. So so here instead of this 2 square we are having the value of bits are 3. So I'm replacing this one like 2 power 3 minus 1 minus 1 to 2 power 3 minus 1 minus 1. So now let us replace 3 with n. Let us consider n equals to 3. Therefore, the actual range varies from minus of 2 power n minus 1 minus 1 to 2 power n minus 1 minus 1. So this is the range for sign magnitude method. Okay. So now what are the important points in our complete discussion which we made the for all the whatever the discussion which we made. The first important point is we are considering the sign magnitude method out of all the three possible methods which are used to represent the negative numbers. In that, in the sign magnitude method, one extra bit is used for the sign representation, where that extra bit is 0, it represents a positive number. If that extra bit is 1, it represents a negative number. And even one more disadvantage which we have seen was there were two representations for 0. One is 100 which represents minus 0 and 000 which represents plus 0, which shouldn't be there. So that's the major drawback. That is the reason why we are going for ones complement, because signed magnitude method failed in this particular context. Okay. Thank you. Thanks for the day. Tomorrow again we will meet with next video.